I'm Neil Charnas, the director of the Institute for Successful Longevity, and we're really pleased to start off 2021 with our very first bound bag by Maxim Dulebenets, who's an assistant professor in the Department of Civil and Environmental Engineering in the FAMU-FSU College of Engineering. He holds his BS and MSc degrees in railway construction from the Moscow State University of Railroad Engineering and an MSc and Ph.D. degree from the University of Memphis in civil engineering with a concentration in transportation. His research interests are pretty broad. They're not limited to some of the following: operations research, optimization, simulation modeling, NP hard problems, mathematical programming, metaheuristics, hybrid algorithms, evolutionary computation, transportation engineering, freight transportation, intermodal freight facilities, railroads, liner shipping scheduling, and GPS data processing. And I'm going to turn it over now to Maxime. His title today is Safety of Older Drivers at Railroad Crossings in Florida. Take it away.
All right. Thank you, Dr. Charnas, for your kind introduction. And also thank you for inviting me to make a presentation at Drawback lecture series. So I'm going to go ahead and make a full screen presentation right now. So as Dr. Charnas mentioned, today I'm going to talk about safety of older drivers at railroad crossings, and most of the things we're going to discuss that are related to specifically to the state of Florida. So in this presentation, I'm going to first provide some background information, then we're going to discuss some causes of the accidents at highway rail grade crossings. Then we'll talk about some safety improvement projects that are conducted in order to improve safety of drivers at the rail crossings. Then we're going to briefly discuss some of the existing challenges associated with safety of older drivers and drivers in general at rail crossings, along with some future research needs and concluding remarks. By the way, throughout the presentation, I'm going to make some pauses, and if you want to ask some questions, we can make some discussions throughout the presentation, and of course, after the presentation, we can have a more solid Q&A session. First, I would want to provide some background information instead of jumping right into safety of older drivers at rail crossings. I would want to kind of discuss a bit about rail transportation. I assume that not everybody is 100% familiar with the rail transportation patterns in Florida rail crossings. So first, it would make sense to kind of give generic and brief introduction, and then we can go towards safety of older drivers after that. So rail transportation plays a very important role in the state of Florida, not just for movement of passengers, but for movements of freight as well. If you look into rail system, it has almost 4,000 rail miles. Most of the railroad segments in the state of Florida are owned by CSX Transportation, more than 55%. Freight transportation actually is a major generator of economic prosperity in the state of Florida. In particular, freight rail transportation supports more than 700,000 jobs, while passenger transportation is not as broad in scope as freight transportation. It still does support about 10,000 jobs. One of the major, of course, along with the economic prosperity and economic importance for the state, there are also some challenges that are associated with the with rail transportation. In particular, there are some safety concerns, especially at the crossings of highway and railway. The segments, the points where railroad intersects highway at the same elevation is called grade crossing. So there are more than 6,000 public crossings. I have here some pie charts over here. So if we look at some basic statistics, overall there are more than 9,000 crossings. So some of them can be at grade, where highway intersects railroad at the same elevation. They call at grade. There are about 9,000 crossings here. Then some of them are overpasses, so there is like a bridge. Not many of them, about 70. And there are also underpasses. Railroad goes under the highway, but there are about 400-something thousand. So out of the 9,000 crossings, 6,000 public, and about 3,000 are private, which means that they are owned by some private entity, and maintenance along with the safety improvement projects have to be executed by private company. So the main focus of our discussion today is safety aspect, focusing on different types of drivers, including older adults. Just to give you kind of some basic statistical information, there are a lot of accidents actually recorded at highway rail grade crossings over the years. So, and this specific statistics given here, this chart is provided for the state of Florida. Between 2009 and 2019, we have over almost 900 collisions with an average of 80 accidents per year. We see kind of that there is a growing pattern. So in from 2009 to 2013, we had somewhere between 60 and 70 accidents, and then starting 2014, we actually started seeing increasing trend. In 2019 specifically, there were over 130. There was a total of 135 accidents. So, and one kind of like critical concern here, we consistently see fatalities, right? Anywhere between between 10 and 15 fatalities we see pretty much every year. So, kind of like more background information. So how can we improve safety at rail crossings? Well, the state of Florida, in particular, Florida Department of Transportation, they're responsible for implementing some safety improvement projects. They're trying to kind of bring some difference to this safety, to these statistics, to these tendencies, and they improve safety and reduce associated number of accidents. How this can be done? Well, they generally implement different types of countermeasures, which can be flashing lights, wigwags, cameras. In some cases, actually, countermeasures do not help. After installing, let's say, a passive crossing that has only stop sign, if they install flashing lights and gates, if this crossing is vulnerable, all these countermeasures do not help. What they do in this case, they actually implement kind of radical countermeasure. It's called grade separation, which means that instead of having grade crossing, they start building either underpass or overpass. Pretty much they eliminate point of conflict between railroad and highway. In some cases, grade separation is actually a very expensive countermeasure. It can go up all the way up to $1.5–2 million per crossing. In some cases, they actually do something different. It's called they abandon crossing. Pretty much they either stop highway movements or railway movements. This is kind of another way to deal with this situation of accidents and improving safety. So along with the for implementation of countermeasures, Florida Department of Transportation also has to keep in mind that after installing countermeasures, there can be delays. Many crossings, like I have here at the bottom of this slide, showing picture of delays. And delays happen, of course, by trains that are blocking crossings, along with countermeasures. When gates are positioned in the horizontal position, traffic cannot move. So this is kind of like bi-objective problem here, along with the reducing number of accidents and selecting appropriate countermeasures. We have to also keep in mind that these countermeasures may cause delays. So another critical challenge that Florida Department of Transportation has to consider when implementing safety improvement projects is limitation in terms of budget. There is a federal program called Section 130. As a part of this program, Florida Department of Transportation receives a certain amount of money every year from U.S. Department of Transportation. Typically, it's anywhere between $7 and $8 million. And this funding is specifically dedicated. The name of the Section 130 program is called Highway Rail Crossing Safety. So they receive this funding to figure out what crossings have to be upgraded and what type of countermeasures should be used for crossings. Of course, we saw in the previous slide there are over 6,000 public crossings for the 7.5 million is definitely not enough. And it becomes challenging to figure out what crossings have to be upgraded and what type of countermeasures should be implemented. Because, of course, cost of countermeasures vary. Installing gate at passive crossing can cost all the way up to $200,000, but each gate structure will have yearly operational maintenance costs. So all the things have to be considered when in trying to improve safety at highway rail grade crossings in Florida. So now we are kind of going to discuss a bit more causes of the accidents. So what are the primary reasons for accidents at highway rail grade crossings, and why do we consistently see fatalities, right? Every year there are more than 10 fatalities in the state of Florida. So, well, of course, there are first group of factors they call the physical characteristics of crossings, which include total number of tracks, pavement type to highway pavement type. There are some highways paved, and some crossings highways actually not paved. So it's either gravel or dirt road. Illumination type, some crossings are illuminated, but many of the crossings are not illuminated, which can be another reason for accidents. Surface type for each crossings, there are different types of surface materials at rail crossings. Number of traffic lanes crossing railroad. Some actually crossings, especially in busy metropolitan areas, have a lot of up to 9 traffic lanes crossing railroad in Florida. So of course, the more lanes we're gonna have, the higher potential vulnerability of drivers we may observe. So functional classification, what type of highway is crossing railroad, and of course, warning device type. What type of protection, existing protection, do we have at given crossing? Again, it can be stop sign or crossbuck, which are common types of, they call it passive protection, or we may have some active protection, which means that there will be some dynamic structure trying to prevent users enter the crossing when train is passing by. And of course, some of the common active types of warning devices are flashing lights and gates. These are kind of like the most typical ones. So in terms of kind of like giving you a bit more statistics, so you may have a better understanding how accidents happen in the state of Florida and how existing warning devices actually associated with these accidents. So some of you may think that, okay, installing active types of protection is gonna help, since we're gonna have some gate arm is blocking traffic, right? The vehicles are pretty much having some resistance, they cannot enter the crossing right away. So essentially, but when we look at the statistics, what happens is that most of the accidents, and I'm showing here numbers between number of accidents between 2015 to 2019, number of crossings that experienced accidents, we see that most of these crossings were active. So the gated crossings actually experience more accidents as compared to the ones that have just stop signs or crossbucks, right? And it's kind of like contradicting, right? Typically, we would expect that having more protection, having more advanced protection would help us preventing accidents, but this is actually the opposite. And why does this happen? Well, the first reason, we have to keep in mind that active warning devices are installed at the crossings with high exposure. So these crossings that we have here, most likely they have more traffic, unlike the ones that have just one stop sign or one crossbar. So they don't have much exposure, they don't have much traffic volume, they don't have much train volume. And also, we have to keep in mind that there are a lot of users who are not very patient. Even if gates are in horizontal position, there will be always some people who are trying to save time and try to drive around the gates that are even closed. This is called zigzag violation. So this is kind of like a primary reason for the fact that installing protection is not always helping at some of the crossings. So coming back also to previous discussion about illumination, plays important role in rail crossing safety. So if we look into statistics again, 151 crossings were unilluminated and they experienced accidents. What state departments of transportation generally do, they actually may look at the illumination statistics and see if crossing is unilluminated and if the crossing experienced accidents during nighttime. The easiest way to upgrade this crossing, just install illumination. It does not require a lot of funding. It does not require to purchasing some advanced types of warning devices. Just install illumination and it can be considered as a low-cost countermeasure in order to improve safety. So some another group of factors they call operational characteristics of crossings. So far we've been talking mostly about physical characteristics of crossing. Operational characteristics of crossing may also be one of the reasons that create potential conflicts and accidents at rail crossings. So the very first factor, which I already partially mentioned, is exposure. Of course, if we have higher number of trains going through the crossings and higher number of vehicles, it's going to create higher vulnerability for a given crossing. Then, of course, maximum timetable speed. Many drivers actually have difficulties perceiving the actual speed of the crossing. Some studies actually show that drivers think that the train is going slower as compared to its actual speed. So the crossing with a higher train speed actually have higher probability of accidents. Then along with train speed, posted speed limit of highway also plays kind of important role. And of course, type of train. We have to check whether the given crossing is kind of like having more passenger trains or freight trains. Passenger trains, they actually are not very long, but they might go at much higher speeds as compared to freight trains. Freight trains generally go about 30-40 miles an hour, but they can be very long. They can be up to 10,000 feet. General railroad companies are trying to have longer trains so they can put more freight on these trains. The long trains are very convenient for transporting bulk. And these trains actually may block crossing for a very long time. They move at, so we're saying, at low speed, and they are very long. So these trains can pretty much create a very long blockage event. So support kind of my previous discussions with statistics. If we look at ADT, at the crossings that experienced accidents between 2015 and 2019, we see a growing trend. There are some crossings in Florida that have up to more than 50,000 vehicles per day. These are mostly urban crossings. And of course, we see that the number of accidents in these crossings is higher as compared to the crossings that don't have much traffic. And also, talking again about the train speed, we see that most of the crossings that experience accidents have very high train speed, up to 80 miles per hour. Most of these crossings, when you see numbers greater than 50, these crossings have a lot of passenger trains. Freight trains generally don't move than 35, 40 miles an hour. And now we are kind of slowly approaching towards very important discussion talking about human factors and aging adults at rail crossings. So some studies show that human factors actually is an important contributor to accidents at rail crossings. In particular, some studies actually discuss that gender can play a very important role. A lot of male drivers actually are willing to take some risky actions at rail crossings. Like, remember, we discussed about zigzag violations when gates are placed in horizontal position, and some drivers are still willing to drive around the gate. So a lot of drivers, female drivers, are kind of more conservative. So gender is important, plays an important role. Speaking specifically about aging adults, there are a couple of studies that actually show that aging adults suffer from more severe injuries as a result of accidents, especially during inclement weather conditions. This particular study by Howe et al. 2017, they studied foggy condition, and they noticed that aging adults have actually higher severity during this type of accidents under inclement weather conditions. There are some other human factors that have to be definitely considered when studying accidents at rail crossings, including driver experience, racial groups, education. Of course, if we have a driver who is often using given crossing, right, the person most likely will know what to do if there is an approaching train. Most likely the person is going to be more careful when entering the crossing as compared to a driver who is entering the crossing very rarely. So another important component, education. Most likely individuals who have advanced degrees, right, who know more about safety issues, especially at rail crossings, are going to be more careful as compared to individuals who are not aware about potential safety hazards at rail crossings, right? So, so far we talked about different factors, including physical, operational characteristics, and human factors. Are there any questions at this point?
Can I ask a brief question?
Yes, please go ahead.
So how much does alcohol play a role in these types of crashes? These remind me very much of kind of wrong way crashes in terms of the factors that are involved. How overrepresented are alcohol or drunk drivers involved in this?
This is actually a very good question. So I have not seen any study which evaluated the effect of drunk driving on crashes, and the reason behind that, they do not report this data. There is one database called, there are two main databases where you can get data for crashes. The first one is called FRA, Federal Railroad Administration Inventory Database, and this database contains basic characteristics of crossings: number of traffic lanes, number of tracks, number of trains, and stuff like that. And the second database where you can get some data is called FRA Accident Database. It does not, they do not report any alcohol there. So they do report age, they do report gender, but nothing else. They do not provide this type of information. So none of the existing study actually evaluated the effect of alcohol on potential accident occurrence. Yeah.
Thank you.
All right. So I'm gonna.
Let me ask a question.
Yes. Mm-hmm.
You said that older drivers tend to suffer the most injuries.
Right.
do they suffer the most accidents? Or are they in?
It varies. If we look at statistics, like based on what I remember, out of 135 accidents that occurred in Florida in 2019, there were about 20 older adults, more aged 65 years or more. So even if you're not going to see a lot of aging adults involved in crashes and involved in fatalities at crossings, we still have to design crossings in a way that they're going to be accommodating aging adults, right, to avoid collisions. Most of collisions are from younger adults because, as I mentioned, many of them are taking a lot of risky maneuvers. Even if, let's say, gates are in horizontal position, a lot of drivers are still willing to cross the crossings to save some time, and they experience accidents. Aging adults generally are not involved in a lot of accidents, but still, if we design crossing the right way, we can even prevent these fewer crashes. Okay. And yeah, any other question?
Well, are most accidents at night?
Most of the crossings actually accidents happen during the day because this is the time when crossings experience higher exposure. At night, mostly there is not much going on. There is not much traffic at the crossings. So during daytime, this is when most of the collisions happen. Okay.
So you mentioned that if these are designed correctly, we should be able to avoid crashes. Are you going to talk about mitigation strategies now, or?
Yeah, I'm going to talk about how this is done, how different departments of transportation implementing safety projects, what type of prioritization methods they're using. I'm going to briefly discuss, and I'm going to highlight what are the challenges, what is not being currently done in order to achieve better safety performance.
Well, and I apologize for missing the first few minutes of your presentation. I do think that most of us have sort of an intuitive grasp of the sorts of crossings you're describing. And so I guess it was just hard for me to think of what other mitigation strategies would be, particularly for older adults.
Mm-hmm.
Besides crossbars and lights and flashing and sound and don't do that signs. I'm a little bit of a loss to think of what else you could do.
Well, I'm going to briefly talk about towards the end, but just to answer your question right away, there are some other things that can be done. There are some alternative methods, like some studies actually using in-vehicle audio alerts. Whenever a roadway user is approaching crossing, there is something in your vehicle. It's like a smart technology. It's saying, okay, there is a train approaching, please slow down, or please stop completely. And these are actually very efficient for aging adults who may have like some issues with vision, right? So you have some alerts in the vehicle. Then you may use some additional painting. There are some crossings they call, there is one countermeasure, they call dynamic envelope pavement markings. They have very bright color, and users actually, when they see these bright colors, they have tendencies slowing down. So and this actually dynamic envelope pavement markings heavily used in crossings in Florida. So there are some ways, there are some alternative methods along with the common ones, and I'm going to briefly talk about it towards the end of the presentation.
Thank you.
Okay. Mm-hmm. All right, let me move on. I just want to make sure I'm not gonna go beyond the time limit, and then we'll talk more towards the end. All right. So speaking of now, we just talked about again different factors that cause accidents at crossings. So now, how are we gonna address them? As I mentioned earlier, there is one federal program called Section 130. And as a part of this program, each Department of Transportation receives X amount of dollars to perform different safety projects. However, the type of safety project is up to Department of Transportation. So they receive funding, and it's completely up to them how to allocate this funding between crossings and figure out what type of countermeasures, what type of actions they're going to do. So, one of the common methods, what they use in order to prioritize crossings, in order to identify the most hazardous crossings, they use some models, which are called accident models and accident prediction models and hazard prediction models. So accident prediction models actually help estimating the predicted number of accidents. They can pretty much tell how many accidents this crossing is likely to have in the following year or multiple years. Hazard prediction models, on the other hand, they don't tell the exact number of accidents. They pretty much define vulnerability. They provide certain index, they call it hazard index, which determines vulnerability of crossings to potential accidents. So in the next couple of slides, I'm going to show you some of the accident prediction, some of the common accident prediction models and hazard prediction models, just so you have better understanding what they do. I'm not going to present all of them. There are more than 20 in the US. So the first one, nationally recognized model, it's called Coleman-Stewart model. And essentially what it does, it estimates the number of the log of number of accidents based on physical and operational characteristics of the crossing. We see here some factors called B and C factors. These are coefficients which are coming from existing protection, what type of warning device is used at the crossing based on urban-rural designation, where a given crossing is located, and number of trucks, whether it's there is one main truck or there are multiple train trucks. So, of course, there are some basic operational characteristics, like we discussed: exposure, average daily vehicle movements, and average daily train movements. So all these factors define the expected number of accidents. So this is Coleman-Stewart model. Another nationally recognized model, accident prediction formula, it was developed by National Cooperative Highway Research Program in NCHRP Report 50. This is kind of like another simple formula. It estimates the expected number of accidents based on A factor, B factor, and T, which is the current train volume per day. So A factor is coming based on ADT, the average number of daily vehicles. The B factor, though, has to do with the crossing physical characteristics. The B factor you can also determine based on number of stop signs, based on the type of protection, and also based on urban and rural designation. Another formula, this is not nationally recognized. It's only used by one state, by the state of Oregon. It's called JACUA formula. The JACUA formula, unlike previous methods, it uses accident prediction for the next 5 years. It does not just give accident for the following years. It gives the number of accidents for the next 5 years. And it estimates the accident prediction based on A factor, B factor, and C factor. A factor is coming from exposure. We have to pretty much look into the number of trains and the number of vehicles. And then it's considering the exposure in a more complicated, more comprehensive way, because it distinguishes trains by type of train, speed of train, and also it does consider all these important factors, unlike the previous formulas. Along with the exposure factor A, there is a hazard rating factor B, which depends on number of blind quadrants, number of trucks, number of lanes, and some other geometric features of the crossing. And the last one, the C factor, it depends on the type of area where the crossing is located, in the urban or rural area, and based on the existing protection. So, so far I just presented accident prediction models, some of them. So what is the main drawback of accident prediction models? Well, accident prediction models, they give us the exact number of accidents, which in reality is very hard to obtain, because there are so many factors that cause accidents. It's hard to obtain very accurate number of accidents. That's why many states do not use the actual number of accidents. They use approximate methods. They call it hazard index methods. Instead of just saying what the exact number of accidents, the hazard index models, they give us vulnerability. They give us some sort of index to determine how dangerous a given crossing is. Just to give you a general understanding, very well-known formula, they call it New Hampshire Hazard Index. It estimates the crossing hazards based on average daily traffic, volume, average number of trains per day, and protection factor, which is some number depending on the type of warning device you have. So again, we're not getting the number of accidents. We're just getting here, we just have an estimation of potential hazard of the crossing. Then another formula, California Hazard Rating Formula. It has some similarities with New Hampshire Index. We pretty much take into consideration the exposure protection factor, but unlike New Hampshire Hazard Index, it also considers accident history. It considers the number of accidents that occurred in the past 10 years. So, which is a good thing, but the main drawback of the formula is that it over relies on the accident data. 10 years is kind of too much time, right? Because in 10 years, it can be a lot of things happening with the crossing. State DOT can come to the crossing and say, hey, let's install some countermeasure. After installing countermeasure, the crossing is going to be completely different. So we cannot count accident history all the time throughout. We have to consider periodical upgrades. So this is the main drawback of the California Hazard Index formula. And then what do we use in Florida? This is something we developed previous year. We had a project with Florida Department of Transportation, and we developed some formula which can be used to prioritize crossings in the state of Florida for safety improvement projects. We call Florida Priority Index. This is a measure which is used for prioritization, and the way it is estimated, we consider the number of vehicles per day, the number of trains per day. Then we also consider speed of trains, protection factor, what type of existing warning devices we use, and accident prediction. And what we use in the accident prediction, the number of accidents in the past years, we actually consider, unlike many other formulas, we consider upgrades. So A is the number of the total number of accidents in the last 5 years, which is the year of the last improvement. We actually compared this formula against some of the well-known formulas, including the ones I just mentioned, New Hampshire Index formula, California Hazard Index formula, Michigan Hazard Index formula, NCHRP formula, and many others. And this actually gave the most accurate ranking. We were able to capture crossings that experience most of the accidents. This is actually very helpful to Florida Department of Transportation because so far they've been using some actually accident prediction model, which required a lot of calibration. It was a huge regression-based model, and they actually had to spend a lot of time trying to calibrate coefficients of the model every year. This one, you see, it does not have much coefficients. It's very easy to work with, and it should last for many years before they want to test it again. So, so far, I discussed kind of main approaches for prioritizing crossings in different states. What we have seen so far, actually, what happens with many of these models, that they mostly consider physical and operational characteristics, right? Each of the models, as you notice, you may notice, they have exposure, right? Every model considers number of trains per day, number of vehicles per day, right? Some formulas do account for certain additional physical characteristics like a warning device type, what type they call it protection factor, what type of protection a given crossing has. Some formulas consider accident history, right, which should give us kind of understanding what is happening with the crossing every year, whether it's experiencing accidents or whether it's not experiencing any accidents. The main challenge is that none of these formulas, and I'm actually saying not just the ones that I discussed, but in general, all the formulas, there are a total of 29 formulas in the US, none of them considers human factors. So you will never gonna see age, you will never gonna see gender, driving experience, like Dr. Wood was mentioning about some additional factors like alcohol, whether driver is using some medicine or anything like that, additional drugs. So none of these formulas account for these factors. So, and why? What is the main reasons for this? Well, as I mentioned before, all this data may not be readily available. Typically, what for the Federal Railroad Administration does, they report only some of the data. We can find age of drivers, we can find gender of drivers. It's reported in FRA accident database, but nothing else. They mostly focus on how many people were injured, whether the driver in the vehicle was injured or killed, how many people inside the train were injured or killed, day of the accident, type of weather, whether hazardous materials were released as a part of the accident. They focus on these type of things, but they do not pay substantial attention to some social demographic characteristics of drivers. So we can't really get this data in order to develop these models. So then in many cases, actually, we have missing records. So if they report accident, they do not provide, in many cases, they have missing fields in the column of age or in the column of gender. So the data is not reported. This is another challenge, accuracy of data and reporting issues. In the meantime, when we try to develop some statistical model, we want to make sure it's robust. We want to make sure that the model is giving us statistically significant results, which can be a challenge in many cases because we don't have that many records. We have about, if we just consider one state, we only have 130 records, 100 records. Not that many accidents. In many cases, it's not sufficient to draw statistically significant results. Along with the just accident events, if we want to come up with some accurate method, right? We don't want to just be biased towards accidents. We want to also consider some other, they call it near misses, right? Events that did not result in the accident, but the train was actually very close to hit vehicle. We want to also analyze the situations to make sure how many, what type of individuals, what type of social demographic characteristics they have when they are involved in near miss situations. At this particular moment, only one state, if I remember correctly, Nevada, there is one formula called Nevada Hazard Index. This is the only formula that considers near misses. None of the other formulas, none of the other methods used by the state DOTs, they do not consider near misses when they select crossings for safety improvements. And again, because of the data, FRA database doesn't have the data. The way Nevada gets it, they work specifically with the railroad companies. The railroad companies report near misses to the state. So, all right, so these are kind of like major issues why we do not consider social demographic characteristics in accident and hazard prediction models. But again, this is critical. Future modeling, future models should definitely consider that because this is common knowledge is that social demographic characteristics of individuals, including age, gender, educational, health conditions, definitely affect their driving performance. Age-related changes definitely impact driving abilities, including hearing, changes in hearing, vision, cognition, perception, and so on. Like I mentioned earlier, there is some portion of aging adults, 65 plus, involved in the accidents in the state of Florida in 2019. Maybe it's not as significant as compared to the total number of accidents, but still we have to design crossings and make them friendly for aging adults, make sure that they feel comfortable when they approach crossings. And how this can be done? How can we come up with the models that do account for social demographic characteristics of drivers? Well, of course, we have to conduct some surveys of population inhabiting some areas that have a lot of highway rail grade crossings, because we essentially have to understand, we have to study the users, the roadway users. So we have to know what kind of education they have. We have to know their driving experience, how often they drive, how far they drive. This will give us better understanding whether they're experienced users or they're not experienced users. Then once we have all this data, we'll have to administer some driving simulator studies. And actually I have it on the next slide. I assume that many of you are familiar with driving simulators. Essentially, driving simulators are partial cabins of each driving simulator can be represented by a partial cabin of some vehicle, and we have here steering wheel. We have some additional devices. Of course, it doesn't look exactly 100% as a real vehicle, but still, each study participant would be able to feel kind of this vehicle environment. And the way what we can do, we can actually design some driving simulation scenarios where vehicle approaching crossing. Here, though, one challenge will be that we'll have to actually consider a lot of scenarios, right? Because we'll need to determine how the effects of a warning device, right? What type of warning device we're gonna have. We will have to change the speed of train. We'll have to change the number of tracks. Definitely, we'll have to consider different type of settings, whether it's urban crossing that has a lot of buildings surrounding the crossing, or whether it's going to be rural crossings that doesn't really have much additional abstractions and so on. So, but once we administer this type of studies, this will definitely give us better understanding. We will be able to determine what are the reasons that may impact safety of different types of users at the crossings. And here, actually, we can explicitly model near miss events where vehicles do not collide with the train, but when it's close, when it's coming close to the point of collision. So, and some concluding remarks. I want to leave a few minutes, about 10 minutes for Q&A. So let me conclude this presentation. So the purpose of this presentation was to discuss importance of rail transportation in the state of Florida, some safety issues associated with the crossings, and highlight some of the main reasons behind the accidents at rail crossings. We identified 3 major causes of accidents, including physical characteristics of crossings, operational characteristics of crossings, and human factors. As a part of Section 130, each State Department of Transportation receives some funding for safety improvement projects to figure out, to determine crossings that have to be upgraded, as well as appropriate upgrading type. And DOTs use particular prioritization methods, which are based on accident prediction or hazard prediction. This method helping them to figure out the top crossings, the most dangerous crossings, and then they can use different countermeasures to upgrade them. The problem with these methods, with the existing accident and hazard prediction models, is that none of them accounts for human factors. We do not see very important social demographic factors that are definitely can be contributors to accident occurrence. So, and what we are proposing here, we are proposing some future studies that have to be administered, including survey-based studies as well as driving simulator-based studies that can help improving the accuracy of these models and can definitely account for different social demographics of drivers. So we've done some of the driving simulation studies before, and they provide here some references. These studies were mostly related to emergency evacuation planning, but of course, the knowledge that we gained from the previous projects can be used for modeling collisions at highway rail grade crossings. Along with the driving simulation studies, we also have done a lot of work in the highway rail grade crossing safety. These studies are mostly related to selection of countermeasures at crossings, as well as evaluation of different models for prioritization of crossings in the US. Again, I provide some references, and the interested readers can definitely visit these publications. As I mentioned earlier, state of Florida, in particular, Florida Department of Transportation, actually is interested in a lot in highway rail grade crossing safety. So a lot of our research has been supported by Florida Department of Transportation, and we definitely see the interest of improving the existing accident and hazard prediction methods, along with the interest of State Department of Transportation. Of course, with this type of work, we can approach other agencies like FRA, Federal Railroad Administration, and NSF, National Science Foundation, USDOT, and so on. So that's all I have now. Of course, I would be glad to share the PowerPoint with any interested individuals. And if you have some questions, you can email me, or in the meantime, we still have some, I think, several minutes left. If you have some questions right now, we'd be glad to address them.
Thank you so much, Maxim. Questions?
I just have one other thought, which was, we have found that lots of data can be missing from the DOT database and ticketing system with some other things. Does it account for type of vehicle? I say this also because I got routed off a road when I was coming back from Orlando the other day, and it routed me through the villages, where I saw, of course, everybody zipping around in their golf carts, and came over some railroad crossings that were just completely unmarked. I had no even idea they were there until I was on them. And I found that a little frightening myself. And I was also thinking that it would be so tempting to game a railroad crossing in a golf cart, where you think, oh, it's just so quick, I can zip around those gates with no trouble at all. Mm-hmm. So I was also wondering if type of vehicle was included in some of the predictors, and whether a captive population like the villages would be a good place to do a survey where there are some of these hazards.
Mm-hmm. Thank you for the question. Not every formula includes type of vehicles. Some formulas, though, like the Jacob formula I mentioned, which is used by the state of Oregon, they disaggregate based on type of train. But when it comes to passenger vehicle, they just assume as is. So, and the main challenge here again is data.
Sorry, I have no idea why that's doing that.
Yeah, again, it's data. When the accident happened, some of the things they do not report, like type of vehicle, I do not believe that the FRA database has it. So most of the models do not consider it. Yeah, but it definitely plays a role.
Yeah, Neil here. I've got a couple of quick questions, I hope. One of them is whether or not the data can be pooled. Is the data consistent enough across states that you could pool it to get more accurate prediction?
Mm-hmm. Yes, it's consistent. The FRA, Federal Railroad Administration Accident Database, they have online platform where authorized stakeholders from each state enter the data. They have like a table and it has all fields there, exactly the same fields for each state. The problem there is that the database allows keep empty entries. So some entries are empty. The organization which is entering, which can be DOT, which can be some local agency, they can leave entries empty, or they may enter inaccurate data. One time I downloaded FRA database and it was showing 140 lanes crossing the highway lanes crossing the crossing, which is definitely wrong. I know it's the maximum can be 9, and this is the person probably messed up number of trains crossing per day with the number of lanes. Something happened, and this is the problem. FRA actually is fighting with the agencies for the longest time, for many years, because the data is not accurate first, and second, they have a lot of empty entries, which creates difficulties when deciding on safety improvement projects.
Yeah, it sounds like kind of FRA is going to have to take a hand in enforcing, much as the case with the FARS database, enforcing clean data entry.
Or they can also make their database, online database, more robust, which can actually tell the user, okay, the value you're entering may not be correct, like a pop-up window, or it cannot even enter the data if you do not specify every single entry. So there are some ways how to improve.
Yeah, there are data checks or consistency checks. Yeah, that could be built.
Right.
Good point.
Right.
Second question was, and this gets along the lines of, I guess, Alice's comment. I'm wondering from a human factors perspective, whether familiar versus unfamiliar rail crossings might play a role in your probability of making a mistake, which is to say, if there's an unmarked crossing and you've been across it a whole bunch of times and you've actually seen a train and had to stop, there's probably, you have a kind of an internal knowledge state that says, as I come along this road, I need to look out for trains. Whereas someone who's using that road for the very first time and doesn't even recognize it's an unmarked crossing could easily, if they're absorbed, listening to music, texting, whatever, make a serious mistake and not check carefully for oncoming trains on that particular crossing. And so I'm wondering whether you could get at some aspects of that using some existing databases like SHARP and SHARP2. Do you know whether SHARP or SHARP2 routes, you could determine whether or not there were train crossings on them, and thereby get some sort of a frequency of exposure for drivers who are local versus non-local?
Yes, right. Go ahead, please.
I was just thinking that was very interesting because it also, with your unfamiliar drivers, they're typically using some sort of driver guidance system. You know, I was listening to my Google Maps at the time I wound up on the crossings. I was not texting, but I clearly wasn't paying 100% of my attention to the road.
Yeah. It would be definitely helpful if we can somehow collect data from additional databases and see if we can have more accurate models to include familiarity, route familiarity, experience, driving experience, how often people driving through the crossing. One important thing here is that each crossing is unique though. If you're familiar with one crossing, it does not mean that you can. Most of probably drivers will be like that. They okay, I know how to work with crossing, but each of them is different, and they have different type of pavement, different type of crossing surface. It can substantially influence how your vehicle behaves once you enter in the crossing. So there would be a lot.
I was thinking more of sort of in the same way that we set speeds for traffic signals differently for crossings where there are a lot of seniors. So the assumed walking speed is slower for those when we set those particular traffic signal durations, like red light duration. so that the pedestrian can get across safely. I'm thinking though of crossings, for instance, someone rents a car near Disney World, you know, they've gotten off at the Orlando airport.
Mhm.
I would start to designate some of the railroad crossings in that immediate area as having high unfamiliarity versus
Mhm.
ones in the villages where the vast majority of the traffic going through, they would have high familiarity.
Mhm. Mhm.
And so in terms of priorities for changing the countermeasures, I would say the
Mhm.
Orlando one gets higher priority if I were building a model. So,
Mhm.
so it's likely trying to get an estimate of the average familiarity or
Mhm.
experience in terms of, say, in-state traffic, out-of-state traffic, and so on. So there may be some, that's why I was thinking of Sharp, which knows, you know, where the vehicle is registered and so on. But I don't know
Yeah.
that there's enough data to be helpful. Anyway, sorry, it's a bit too speculative.
Well, thank you for the suggestion.
Any last minute questions? We are out of time.
Well, I thought that was very interesting. I just want to thank you for the presentation. I am going to have to jump off, but thank you very much.
Thank you, Alice.
Thanks again, Maxime, and thanks to the audience for some very good questions.